Mars is the fourth planet from the Sun, and it's the planet that bugs scientists the most because it's a planet that can be very much habitable, but no such discovery of life has been found on it yet. After Earth, Mars is considered the place with the most chance of habitability because it resembles many features with Earth, like similarity in rotational period, rocky terrain, seasonal weather patterns, which means similar axial tilt, and polar ice caps. Are there any forms of life that have been found on Mars yet? Well, currently no. But scientists are continuously looking for life on Mars, even in the simplest forms, microorganisms like bacteria. For there to be life, there needs to be water. You won't believe it, but there's actually much more water than you think on Mars, in the form of polar ice caps present on the North and the South Pole. The entire Martian surface can be covered with about 35 meters of H2O. But since the temperature is almost always below minus 60 degrees Celsius or minus 76 degrees Fahrenheit on Mars, that water remains frozen all year long. Another important factor for life to thrive is atmosphere. The composition of Mars's atmosphere is 96% carbon dioxide, 1.9% nitrogen, 1.9% argon, and 0.1% oxygen. Most of the oxygen on Mars is also found in the rocks in the form of Fe2O3, which is iron oxide, that gives Mars its red color. NASA's MOXIE experiment on the Perseverance rover has successfully converted Martian CO2 into oxygen, proving that future missions could generate breathable oxygen from the atmosphere. Mars missions. Till date, a total of 7 rovers have landed on Mars. 5 of them sent by the United States, one was sent by the USSR, and one by China. Only 2 of these 7 rovers are active right now, Perseverance and Curiosity. The exploration of Mars began with the Mariner 4 flyby in 1965, but it took only 22 pictures closely. 4 years later, in 1969, Mariner 6 and Mariner 7 flew past Mars and again returned images to NASA. Then, in 1971, Mariner 9 arrived at Mars, but then a huge dust storm took place and the spacecraft had to be put in semi dormant mode. Before the autumn of 1972, Mariner 9 had clicked about 7,300 photos. Viking spacecraft went to Mars in 1976, followed by the Phobos spacecraft that was launched by the Soviets in 1988. This is a list of the rover missions carried out to Mars. 1997, Sojourner found evidence of water under the surface. 2004, Spirit rover discovered silica-rich soil. 2004, Opportunity rover traveled 45 kilometers and found hematite blueberries. 2012, Curiosity rover analyzed radiation, methane, and found a lake bed. 2021, Perseverance stored rock samples and found river deltas. 2021, Zhurong from China confirmed water presence, studied magnetic fields. Energy needs on Mars is another factor for life. Energy. Our options for sustainable energy on Mars. Solar energy. Mars only receives about 40% of the solar energy that we receive on Earth, so this is out of option. Wind energy. Mars's atmosphere is only about 1% of the Earth's atmosphere, making it too less to generate power. And besides, Mars has huge dust storms that can ruin the electronics. Hydropower. Seriously? Do we even need to discuss this? Anyways, moving on. Another way of energy on Mars is that our manned ships or unmanned ships bring their own nuclear power cell or battery like the one Voyager 1 used, in which a small piece of plutonium 238 is used to generate electricity via the decay of the radioactive element. Energy on Voyager 1. Voyager 1 has three radioisotope thermoelectric generators or RTGs mounted on a boom. Each MHW RTG contains 24 pressed plutonium 238 oxide spheres. The RTGs generate about 470 watts of electric power at the time of launch, with the remainder being dissipated as waste heat. The power output of the RTGs decline over time due to the 87.7-year half-life of the fuel and degradation of the thermocouples, but they will continue to support some of its operations at least 2025. Besides nuclear power, we can also use geothermal energy, or should I say Mars thermal energy. Haha, so as you know that Earth has a core and the core is very hot. So in the same way, Mars also has a core and it's very hot. We can use this core to produce energy like we sometimes do on Earth. This also doesn't rely on the sun or the atmosphere. In conclusion, Mars's harsh conditions make complex life unlikely, but microbial life, past or present, remains possible. Ancient water hints that life may have thrived underground. To uncover the truth, we must explore further, drilling deeper for biosignatures. Even a small discovery could reshape our understanding of life in the universe. Be sure to check my website at earthandbeyond.co.in. See you in the next one.